Hello students, today we are starting chapter number 8, Gravitation for the 11th standard physics. So in this chapter, first of all we'll cover the theory lecture which is given in the NCERT textbook, and after that we will be doing certain numericals over there. Okay. So in chapter number 8, Gravitation, what is discussed here? Let us see. There was an Italian physicist, Galileo, who recognized the fact that all bodies, irrespective of their masses, are accelerated towards the Earth with a constant acceleration. And Galileo said that Earth is the center of the solar system, and Sun and other planets move around it. Okay. So about 2000 years ago, Ptolemy has given geocentric model. Geo means Earth, centric means toward, at the center. Earth is at the center and all the sun and planets are revolving around it. That was geocentric model for the celestial objects. So all the planets and the sun are revolving around the Earth. That was geocentric model about 2000 years ago. After that, sun is at the center and all other planets and the Earth are revolving around it. That was heliocentric model. Helio means sun, centric means sun is at the center. So heliocentric model said that around 400 years after that, this theory was propagated, the heliocentric model. So Nicholas Copernicus, who proposed this theory, who proposed this model that the sun is at the center and all the planets and Earth is revolving around it, was punished by the church for his discovery, because all their lectures and all their beliefs were based on that Earth is at the center of the solar system, while Copernicus was saying that sun is at the center of the solar system. So he was punished. Tycho Brahe, he was a scientist hailing from the Denmark, and he spent his entire lifetime observing the planet with the naked eye, because the telescope was not invented by them. Telescope was not invented by them. So by the naked eye, he has recorded all the observation and compiled his data. Later on, his assistant, John Kepler, his assistant, analyzed the data कि गुरुजी क्या लिख के गए, वो डेटा को एनालाइज करने के बाद उसने 3 लॉज निकाले. These are known as the 3 Kepler's laws of motion. ठीक है. What is the Kepler's law? 3 Kepler's law. First law is the law of orbits. The law of orbits says that all the planets move in the elliptical orbit with the sun situated at one of the foci. Foci is the plural word of focus. So one of the foci of ellipse. Okay? Ellipse is a figure of such type you see. Okay, it has 2 centers. Sun is shown at one of the center S, another center is S dash of the ellipse, and this PA, this is known as major axis. This is denoted by 2A, and this BC is known as minor axis and is denoted by 2B. Okay. Hello dear friends. Today we are going to start chapter number 8 Gravitation, 11th standard science. So first of all, we will cover the theory part along with certain numericals so that you understand the concept of this chapter. Okay. So chapter number 8, gravitation. What is there in that chapter? About 2000 years ago, a geocentric model was placed before the world. What the geocentric model was saying? Geocentric model was saying that geo means earth, centric means at the center. Earth is at the center and all the planets along with the sun revolves around earth. So earth was the center of the solar system. That was geocentric model. And that model continued for hundreds of years. Okay. So 400 years later, a more elegant model in which the sun was at the center around which the planets revolved, that is known as the heliocentric model, was already mentioned by Aryabhatta, 5th century AD. And then a Polish monk, Nicholas Copernicus, proposed a definitive model in which planets moved in circles around fixed central sun. Means helio means sun, center means at the center. So sun is at the center and all the planets move around it. Earth and all the planets move around the sun. That was the heliocentric model. But when Nicholas Copernicus introduced this model, so church punished him. Why the church punished him? Because at that time, gospels of the church and other lecture given by religious leaders were based on the fact that Earth is at the center of the solar system, while Nicholas Copernicus' theory was contradicting that. So they punished him. At the same time, as Galileo was, there was a scientist known as Tycho Brahe. This Tycho Brahe, hailing from this Denmark, spent his entire lifetime recording the observation of the planet with the naked eye because at the time telescope was not invented. So he seen the planets and the stars with his naked eye and he's recorded his observation in his book. Then his assistant John Kepler, almost taken 40 years, and he could extract whatever his Guruji has written. Okay. So he came with three laws known as Kepler's laws of motion. So we will be discussing what are the three laws of Kepler. Okay. So Kepler's laws में पहला law क्या है? Law of orbits. All the planets move in elliptical orbit with the sun situated at one of the foci of the ellipse. So what is the shape of the ellipse? This is the ellipse you see, in which this PA is known as the major axis. S and S dash are the two centers of the ellipse. This BC is the another diameter of the ellipse known as the minor axis. Major axis PA is generally represented by 2A. Minor axis BC is generally represented by 2B. From center to one extreme, this distance is known as semi-major axis. From center, this distance or this distance up to C from the center or distance up to B from the center is known as the semi-minor axis. So what he proposed in the law of orbits, all the planets move in elliptical orbit with the sun situated at one of the foci. The sun is either here or at this center. Okay. So both the figures will be symmetrical. Anywhere you can assume. So what is the ellipse? Let us know about the ellipse. How we can draw the ellipse? You see this figure. F1 and F2 take two pins and fix these pins on the board, wooden board, and take a thread, loose thread, okay, and straighten this thread with the help of a pencil outside so that this F1T and F2T are straight, and move this pencil keeping it stretched outwards, keeping it stretched outwards, बाहर की तरफ खींचते हुए, so that कि F1T और F2T स्ट्रेट लाइन रहे. आप इस पेंसिल को ऐसे ऐसे घुमाते रहेंगे, ठीक है, और ऐसे ऐसे पूरा घुमाते रहेंगे. यहाँ पे आके थ्रेड को इस पिन के ऊपर से निकाल देंगे, उसके बाद फिर से ऐसे ऐसे घुमाते रहेंगे, तो ये कर्व ट्रेस हो जाएगा जो कि एलिप्स है. ओके, दिस इज वन ऑफ द मेथड्स टू ट्रेस द एलिप्स. So this was the first law, law of orbits. Second law is law of areas. What is the law of areas? He said that the line that joins planet to the sun sweeps equal areas in equal intervals of time. Now this is sun and this is a planet. This is a line joining sun and planet. Now this is going from P to P dash, then sweeping area, this area it is sweeping. Okay. So it is saying that line joining the sun to the planet sweeps equal areas in equal intervals of time. So this line S to P moves and becomes S to P dash. So this area has covered in delta t time, suppose. Then you take delta t time when the planet is near the sun in these two locations. So when the planet was there, after delta t time it reaches here in such a way that this area is equal to this area. So we say that the areal velocity is constant. The other way of saying this law is that areal velocity dA by dt delta A by delta t is equal to constant. Now a very important observation can be made here. You see, planet is moving from P to P dash, so this distance is less, and here the planet is moving from this place to this place, so distance covered is more. So distance covered is more in the same time, so that means speed is more or velocity is more. So planet is having more velocity here and the planet is having less velocity here. Okay, so when the planet is farther away from the sun, it moves slower, and when the planet is nearer to the sun, it moves faster. Okay. Now third law of Kepler is law of periods. What is law of periods? Every planet has its time period of revolution around the sun. Earth is having a time period around 365 days. Moon is having a time period of about 27.3 days around the Earth. So every planet is having the time period, and the time and it is following, every planet is following almost elliptical orbits. And suppose the semi major axis of the orbit is small r, then time period square is equal to kr cube, meaning time period square is proportional to r cube. R is semi major axis. Okay, so t square is equal to constant times r cube. This is the law of periods. This is the third law of Kepler. Okay. The square of the time period of revolution of a planet is proportional to the cube of the semi major axis of the ellipse traced out by the planet. Now let us see how the gravitation was discovered. So this law of areas, which we have just seen, law of areas of the Kepler second law, can be understood in another way. Let us see. Let the sun be at the origin and the position momentum of the planet to be denoted by r and p. Suppose this is a planet and it is moving around from here to here, it is moving. Okay, so velocity is v, planet velocity is v, its mass is m, and its momentum is p. So what is the distance it covers in 1 second? Distance it covered in 1 second is v, and this is the position vector r joining the sun in the planet. So what is the area of this triangle? Area of this triangle is almost, if this is small, then we can apply half base into height formula. So base, we can take this and we can take this, or we can take the vector notation. Vector A cross B gives us the area of the parallelogram containing A and B vectors. So half of A cross B, that will be the area of the triangle containing these two vectors. So here are two vectors, one position vector R and another position vector, this V. So what is the area of this triangle? Area of this triangle is V delta T. Okay, V delta T is the distance covered in delta T time, okay, by the planet. And another vector is R. This is this displacement, not the distance. This is displacement V delta T. So R cross V delta T, half of that will be the area of that triangle, shaded region I have just shown you. So what is delta A upon delta T? Delta A upon delta T comes out to be half R cross V. Now half R cross V is there. So multiply by M and divide by M. So upper side becomes MV and lower side M comes. So this becomes half R cross P divided by M. And what is R cross P, you know? R cross P is L, angular momentum L. So angular momentum divided by 2m, L by 2m. Delta A upon delta T is equal to L by 2m. This formula is to be remembered. Okay, sometimes directly it is asked in the question. Delta A upon delta T, aerial velocity is equal to L by 2m, where L is the angular momentum of the planet. M is the mass of the planet. Now, what is universal law of gravitation? So Newton was an ingenious scientist. He has applied his mind and seen that moon is revolving around the earth, and whatever thing you throw above the earth on the surface of earth, that will come down. Whatever thing you throw above will come down always. Okay, so he calculated the acceleration for the moon around the earth. Acceleration of the moon around the earth. Moon is revolving in a circular orbit, so it is following a centripetal acceleration. It is having a centripetal acceleration around the earth. So he has calculated acceleration around the earth, v square by rm, v square upon r, centripetal acceleration of the moon. So v is equal to 2 pi r upon t. V is 2 pi r upon t. So v square 4 pi square rm square upon t square, and divide by this rm cancels out, so 1 rm is remaining. So am is 4 pi square rm upon t square, where t is 27.3 days, right? Rm is radius of the moon around the earth at the center, radius of the moon orbit. So if we calculate this, this comes out to be a very small value, 0.0027. This comes out to be a very small value, 0.0027. So let us write here this value. Acceleration of moon comes out to be 0.0027 meter per second square. And then he calculated anything which is thrown upwards will come down. So what is the acceleration at the earth? Acceleration at the earth he calculated as 9.8 meter per second square. And if we find the ratio of these two, g, acceleration on earth, divided by the acceleration of the moon, comes out to be 3600, a factor. Moreover, he also observed that the radius of Earth around the sun and radius of moon around the Earth, if we take the ratio, it comes to be 1 by 60. It comes to be 1 by 60. So if we take that radius of Earth upon radius of moon's orbit, that comes out to be 1 by 60. So if we take the square of that, so this comes 3600. Okay. So Rm upon R is what? 3600. So he has seen that acceleration is inversely proportional to R square. Acceleration anywhere is inversely proportional to R square, radius of the orbit. Acceleration of that planet is inversely proportional to R square. Then he came with his idea of universal law of gravitation. That is why he called this law as inverse square law. So what is inverse square law? Later on it will come. F is equal to G m1 m2 upon R square. This is inverse square law. So that was Newton's ingenious method by which he came to know about this. Okay. Now next, we will be studying about the what is the Newton's law, scalar form of the Newton's law. So you see, scalar form of the Newton's law is given here. F is equal to G m1 m2 upon R square. For what thing it is? If there are two masses, m1 and m2 are two masses kept at a certain distance r, then the force of attraction between them is given by this formula, G m1 m2 upon R square. See that this force of attraction is inversely proportional to R square. So that is why it is called the inverse square law. Coulomb's law also is an inverse square law. And this force is depending on the product of the masses m1 and m2. And G is universal gravitation constant. Its value is constant whole universe. All of the universe, this value is constant. So this is scalar form of the Newton's law. Now what if we want to write the vector form of the Coulomb's law? To write the vector form of the Coulomb's law, let us see the figure below. This is the figure in which this is x-axis, y-axis and z-axis. M1 is located here, position vector R1. M2 is located here, position vector R2. And we want to write the expression for the force. So F12 if we want to write. Suppose if we want to write F12. So how do we write that? Suppose we want to write F12. So what F12 denotes? F12 denotes the force on 1 by 2. Force on 1 by 2. So now let us see here. Force on 1 by 2. So what is the nature of the force on 1 by 2? It is attractive. So in this direction, we have to put the unit vector showing the direction of this force. What is the amount? Amount is given by G m1 m2 upon R square. So F12 is given by G m1 m2 upon R square. This is the amount multiplied by unit vector R in this direction. Now this unit vector R, what is this? From the triangle law, we see here, we see that vector R1 plus vector R is equal to vector R2. So what is vector R? Vector R is equal to vector R2 minus R1, right? So vector R is equal to R2 minus R1. So we have to write unit vector. So in place of this, we will write G m1 m2 upon r square and unit vector r. Unit vector r is vector divided by the magnitude of the vector. Vector divided by the magnitude of the vector. What is this r here? This r is basically the magnitude of r2 minus r1. So vector r is what? R is magnitude of this vector. That means it is magnitude of r2 minus r1, right? So here it comes r2 minus r1 whole square, or you can write this as r. Either you write this as r or you write this r as magnitude r2 minus r1 whole square. In both the way, cube will come here. So see vector r written here means r2 minus r1 written here, magnitude and whole cube comes here. So this is vector form of Coulomb's law. Okay, this is the simpler form. G m1 m2 upon r square unit vector r. Unit vector r shows the direction of the force. So we have written F12. F12 is this G m1 m2 upon r square r cube and इधर यहाँ पे क्या आएगा r2 minus r1. Suppose if we want to write F21. So as per the Newton's third law, M2 जितना फोर्स M1 पे लगाएगा उतना ही फोर्स M1 M2 पे लगाएगा इस डायरेक्शन में. ठीक है, तो F21 क्या होगा? F21 है जो स्केलर वैल्यू है वो तो सेम हो जाएगी, स्केलर वैल्यू विल रिमेन सेम. तो आएगा G m1 m2 अपॉन r स्क्वायर विल रिमेन सेम, और यूनिट वेक्टर में हमारा माइनस यूनिट वेक्टर आ रहा है. ओके, so we see that Newton's third law is applied here. F12 force on 1 by 2 is equal to minus of force on 2 by 1. Newton's third law is applied here. Understood? So some misleading things are there in this book. You just don't be confused. You understand what is being told here. Unit vector r will be attached here when we find the force on 1 by 2, and this unit vector minus r will be attached when the force on 2 by 1 it will be calculated, right? समझ में आ गया? Now what is the case? A single mass m1 is there and we have to calculate the force due to 2, 3 and 4. This is m2. Let me write, it is not clear. This is m3 and this is m4. So we have to calculate force on mass 1 because of all the three. So we will take pairs one by one. This is known as superposition theorem. First of all, we will calculate the force on m1 because of m2. Then we will calculate the force on 1 because of m3. And then we will calculate force on 1 because of m4. And we add them vectorially. So that vector sum will be the total force on mass m1 due to all these three masses. Okay. So what is F1? F1 will be F1 will be sum of force F1 vector sum of F1 2 plus F on 1 by 3 plus F on 1 by 4. These three things we have to write and add. So what is F12? Let us write it here. If we write F12, force on 1 by 2 is what? G m1 m2 upon r12 r12 vector magnitude. Let me write a square here. Okay, and then I have to attach a unit vector. Let us see unit vector direction. We are calculating force on 1 by 2. This is 1, this is 2. Force on 1 by 2 is attractive in nature. This will attract this one. Similarly, this will attract this one, and similarly this will attract this one. So arrows will be in this direction. So we have to write unit vector in this direction, in the direction of arrow. So that vector has been represented in this book as R12. Vector pointing from 1 to 2 has been represented as R12. Okay, so I will write here what? Unit vector R12. Okay, and unit vector R12 I have written here. Similarly, I will add another term G, the force, this one, M1 M3 upon R13, R13 वेक्टर मैग्नीट्यूड होल स्क्वायर, ये हो गई स्केलर वैल्यू. उसके बाद यूनिट वेक्टर अपने को इसमें अटैच करना है, तो दिस यूनिट वेक्टर R13 आई विल अटैच, वेक्टर R13 यूनिट वेक्टर आई विल अटैच. Similarly, the third term I will write G M4 M1 divided by R14 unit vector, vector whole square, and unit vector R14. Okay. Now this you can write vector R12 divided by the magnitude of R12, and that magnitude of R12 will be multiplied here, so it will become R12 cube. Okay, so cube form can also be written. This is also correct with unit vectors. Okay, so vector sum of all these three forces give us the force on one mass M1, and this is known as the superposition principle. Okay, see, they have written in the form of unit vectors. Okay, now there is a question. See this question: three equal masses of m kg are fixed at the vertices of the equilateral triangle ABC. What is the force acting on the mass 2m? Mass 2m is placed at the centroid G of the triangle. Okay. Then what is the force if the mass at the vertex is double? Mass at the vertex double कर देंगे तो कितना हो जाएगा force? Let us see this question. This question can be done in many ways. One of the method is shown here. See. Now see. This is your equilateral triangle. A, B, C, three vertices are there. A, mass M is there, mass M is there, mass M is there. This is centroid. What is the centroid? Find out the midpoint of AC and join it with this line. Find the midpoint of this line, join with the other opposite vertex. Then you get the centroid. What is the property of the centroid? 2:1 ratio. This ratio, this divided by this gives us 2:1 ratio. So it is given that centroid is 1 meter away from the vertex. So this is 1 meter, 1 meter, 1 meter. So no need to go into detail. So let us find the force on this centroid mass 2m by any of the mass, suppose from A. So you see m mass will attract this 2m mass. So direction is this. So force is in this direction and its unit vector is shown J. So force on G by A is attractive, and in the y direction बताने के लिए unit vector J बताया गया है. तो G m1 m2 upon r square into unit vector J. What about the other masses? इसकी वजह से इस पे ऊपर फोर्स क्या लगेगा? इधर लगेगा, in the direction of arrow shown. अब इधर यूनिट वेक्टर लिखना है, तो इधर यूनिट वेक्टर लिखने का क्या तरीका है, मेक अ line here. So by symmetry, this 30-degree angle is there, equilateral triangle is there. So this unit vector, whatever it is, will be written like this is 30-degree. So cos 30 component of this unit vector is in this side. Okay. So we will write for this side minus I, because x direction component unit vector is I, x, y, and z. Three directions are here, the unit vector I, here the unit vector j, and here the unit vector k. So we will write I and whatever value is there, so cos of 30, I cos 30, and one component in this direction, that is in the minus j direction. So we will write minus j sine 30. So this unit vector will be represented by, this unit vector will be represented by minus I cos 30 minus j sine 30. Let us name this unit vector as GB. AF GB unit vector. Okay. Now what is the unit vector in this direction? Because we have to write the expression of force like this, in this direction also, in this direction also. First of all, we have to find out this unit vector. So this will be written as plus I cos 30 by cos rule, and this here it is minus j sine 30. So unit vector FGC in the direction of GC, this unit vector will be written as plus I cos 30 and minus j sine 30. Okay, now we can write the full expression. What is the force on 2m mass capital centroid by B? G m1 m2 upon r square, and the unit vector in this direction. We have already written unit vector FGB unit vector minus I cos 30 minus j sine 30. Similarly, FGC from G to C, FGC. Okay, what is that? G m1 m2 upon r square and plus I cos 30 minus j sine 30. Now this magnitude is same in all the three. If we add all the three, or by superposition theorem says that force on this is sum of all these, vector sum of all these forces. So vector sum of all these forces, if we do, we see this vector will cancel out. Okay, minus times j sine 30, sine 30 is half. Okay, so minus half times this coming with j, and minus half times this coming with j. Okay, and this will cancel this. That means the total sum is 0. What is the total sum? Total sum comes out to be 0 in this case. And total sum comes out to be 0. That means the force acting on this mass 2m because of m masses kept at the vertices of the triangle will be 0. This is one of the method. So there are other methods also. Okay. What we can do, I have just hint this and go ahead. See, you calculate this force is there, this force is there, and this force is there. There are three forces. What are the magnitude of these three forces? Magnitude of these three forces is same, G m 2m upon 1. These are the magnitudes, because this distance, and this distance are same. So what you do, take these two forces, GB and GC. Okay, force on G because of mass at B and because of mass at C, and calculate the resultant by the geometry. What is this angle? This angle between the two forces is 120 degree. I am discussing the second method. Okay, so let me write it here. Let me write it, rewrite it. This is one force, this is another force, this is. Now all the three forces have same magnitude. magnitude of all the forces is Gm to m upon 1. Okay. Now, this is 120 degree. What is the resultant of these two? Resultant is equal to under root p square plus q square plus 2pq cos 120 degree, and this comes out to be under root 2f square, and this cos 120 degree what? Cos 120 degree is cos 180 minus 60 cos 180 minus theta ASTC rule minus cos 60. Cos 60 is half, so minus 1 by 2. Cos 120 degrees minus 1 by 2. So 2f is square minus plus 2f is square into minus 1 by 2. So it comes out to be what? Under root 2f is square, and this 2 cancels out, minus f is square. So remaining under root f is square, so comes out to the f. Now this vector is directed in this direction. Resultant vector is this, and the magnitude is f, which is equal and opposite to this vector. So cancelling out this vector. So resultant of these two vectors is this, and one vector is this. Both are equal and opposite vectors, and therefore cancels out. So the resultant of these three forces will be 0. Resultant of the three vectors will be 0. This is an important result. So what is the total force? Total force will be 0. Okay, so I have discussed the another method also. Now you see, now there are two important things to understand. The proof of these results are not shown here, but these are important. First is the force of attraction between a hollow spherical shell of uniform density and a point mass situated outside it is just as if the entire mass of the shell is concentrated at the center of the shell. That means this is a hollow spherical shell, and this is a point mass, and this is capital M. Okay. If we want to calculate the force between them, then we will assume that this total mass M is concentrated at center of mass, and we will calculate the force between them. Okay. Mass of the shell is concentrated at the center of the shell. Okay. Another theorem, important theorem, whose proof is not there, is the force of attraction. The force of attraction due to a hollow spherical shell of uniform density on a point mass situated inside it is 0. What it says, let me discuss. Suppose a hollow spherical shell is there, and a point mass M is inside that. Total mass M is there of the hollow spherical shell. So if we calculate we take a small mass M here and calculate the force on this. So the force on this will be in this direction. This piece will attract this one, and take the another piece which is in the opposite direction. This piece will attract in this direction. This piece will attract this in this direction. Okay. So proof is not given, but the force on this will be 0 because of the total shell. This is shell. Okay. So if a mass M is kept at the center inside the thin spherical shell, the force on the mass due to thin spherical shell will be 0. Okay. Gravitational force will be 0 on that. That is an important theorem. The force of attraction due to a hollow spherical shell of uniform density on a point mass situated inside it is 0. Okay. Now let us take further what is gravitational constant capital G, which we have discussed earlier. Capital G we have to calculate. So practical arrangement is shown here. Cavendish is done the Henry Cavendish has done this experiment. This is a wire or a string, and from that wire a rod AB is hanging. At a point a mass small m is there. At this point A, m mass is there. At this point B, m mass is there on the rod. Let us place at a distance d from both the ends capital mass m. This is also capital mass m, and this distance is also d. At the similar distance, if we kept this masses capital M, then you see that a small mass m is attracted to this capital M. So it will be attracted in this direction, and this will be sorry, this will be attracted in this direction, you see. So it will form a couple, okay? And because of the couple, this rod AB will be having this position after certain time, and this angle is theta. It has twisted around theta angle. So what is the force of twist? This will have restoring twist. Similar spring में क्या होता है? Spring में होता है restoring force F is equal to kx. If the spring is stretched or compressed by x amount, तो restoring force develop हो जाता है F is equal to kx. तो स्ट्रिंग या वायर के केस में क्या हो जाएगा? यहाँ ट्विस्ट हो रही है वायर के अंदर या स्ट्रिंग के अंदर, तो फोर्स ऑफ ट्विस्ट क्या हो जाएगा? वो हो जाएगा एफ एक्स एफ इज इक्वल टू के एक्स के हिसाब से हो जाएगा यहाँ पे टाउ इंटू थीटा. टाउ इज द ट्विस्ट कॉन्स्टेंट ऑफ द स्ट्रिंग, थीटा इज द एंगुलर डिस्प्लेसमेंट. ओके, टाउ थीटा, दिस इज द फोर्स ऑफ द ट्विस्ट, restoring force, restoring twist. Okay, and this is the force due to couple made by these two forces. What is the amount of the couple? Couple is one of the force, so G m1 m2, G m1 m2 upon r square formula. So this force will be calculated. Okay, force will be calculated. One of the force into distance between them. Distance between them is L, so multiply by L. Okay, so we get the this couple. Okay, restoring torque, tau theta will balance this, and therefore under this balance this will be in the equilibrium position. It will be staying like this. So G m upon d square into L is equal to tau theta, and from this expression we can calculate the G. Value of G comes out to be 6.67 into 10 to the power minus 11, right? Newton meter square per kilogram square. So this is because all other things are known. So capital M is known to us, small m is known to us, d is known to us, length of the rod is known to us, and theta we can measure in radians. Twist constant of the string, what type of string or wire has been taken, that also we know. So all other things are known. So it has been calculated as 6.67 to 10 power minus 11 Newton meter square per kilogram square. You have also to remember this. Okay, so today we have completed up to this topic, and now onwards, acceleration due to gravity of the earth, when we go above the surface of earth, when we go below the surface of earth, we will discuss in the next lecture. Okay, okay students, bye.